So we're going to talk about linear equations. This is chapter 1, section 1. So linear equations, here we have an equation. That means we have an equal sign. So we're going to actually solve for the variable. So here we're going to solve for x. So used to this, you can pause the video and solve for it, and then continue to watch it. Alright, so we're just going to go ahead and two-step equation, subtract 2 on both sides. Usually the best way to go about this is to kind of do the orders operations in reverse. You don't necessarily have to. We're just trying to figure out what is the value of x. So after we subtract 2, then we divide on both sides by 3. You just have to do it on both sides, right? That's the big thing. So x is equal to 5/3. Okay, here's a little bit more complicated one. If you can just go ahead and pause the video and want to try it, go ahead. If not, you can just take notes. Okay, so here we have multiplication between these two factors, multiplication between these two, actually not multiplication between this one, this 7, but this negative, we can distribute that negative. So if we distribute that negative, we don't want to distribute a -7, just that negative. Okay, so we get negative x minus 5. Now we can bring down this 7. So we have 7 minus x minus 5. Well, that's a positive 7 and minus 5. So that's 2 minus x. This side we can distribute that 3x plus 6. Now we have a few steps that we can do. Again, it doesn't really matter which way you go, as long as we get x to one side and my regular numbers on the other. So I'm going to move this negative x over by doing the opposite. You always move stuff over by doing the opposite. Okay, move the 6 over. Instead of adding 6, we're going to subtract 6. So 4x equals -4. Now we can go ahead and do the opposite. Instead of 4 times x, we're going to divide by 4. We're doing the opposite or inverse or reciprocal, however you want to say it. It's basically the inverse. And we get -1. And then we can always check. Whenever you're solving, you can always go back to the beginning and check. So we have x equals -1. So we can plug that in. 3 times x plus 6. -3 plus 6 is +3. Now we can do the other side. 2 minus x, which is -1. That's 2 minus a -1. That's a 3. So they both sides equal 3 when I plugged it into this part right here. Okay, now we're getting some vocabulary a little bit. This will be on your quizzes and on your test to identify if it's what kind of statement it is, whether it's conditional, a contradiction, or an identity statement. And a conditional statement just means that x is conditional. It has to meet a condition, a very specific condition. So if it's a conditional statement, x has to equal some number. Okay, it just equals a number. So like, for example, x equals 4 would be a conditional statement. That is just basically you have one solution. So whatever equation we're dealing with, it's a conditional statement if x has to be a single number, right? Just one number. On a contradiction, that means when we're solving an equation, the x's are going to drop out, or the variable is going to drop out, and we'll just be left with, after we simplify, we'll be left with something like 7 equals 8, a contradiction, right? 7 does not equal 8, that's a contradiction. And that usually happens when the x's cancel out. Or you'll have like 3x on one side, say plus 6 equals 3 times x minus 12 or something like that. So after you distribute the 3, you'll have 3x on this side and 3x on this side. And then when you subtract a 3x, you have no more x's. They cancel out. They go to 0. So at the end you would get 6 equals what, -36. And that's a contradiction, right? That's not true. So there we would have no solution. Alright, the last one is an identity statement. basically it's an equation where the x's will drop out again. So just like the last one, the x's will drop out, there's no x's, and then we'll just be left with a number equaling a number. But this time, the number will equal the same number. It's true. 7 does equal 7. So what that means is I can plug any number in for x, any number in for x. So say if I get 3x, we'll keep with the 3x thing. 3x plus 6 equals x 3 times x plus 2. Right, so when I multiply this out, 3x plus 6, and then look, I get 3x plus 6, the exact same thing. So now when my x's cancel, or subtract to 0, I get 6 equals 6. That's a true statement. So that means I can plug any number I want to in for x, and it would still be true. The original one, the conditional one, means I can only plug in x equals 4. That will only get me a true statement. If I plug in any number but x equals 4, I'm not going to get, it's not going to be true. The contradiction, I can't plug anything in for x. It will never be true. And the last one, I can plug anything in for x and it will be true. So like 7, if I plugged in 7 and 7, I get what? 21 plus 6 is 27. 3 times 7 is 21 plus 6. It's the same exact thing. Any number I plug in, it will be true. Contradiction, I can't plug in anything. Conditional, I have to plug in one single number. Alright, solving for a specific variable. Again, these are a little more complicated just because they don't have any numbers, so students just get confused on this. And that's okay. It'll just take some time. So just look, it's just like in science, you have a formula and you're solving for a variable in that formula. That's not already solved for, right? This one solved for I. I equals PRT. So I is already solved for, but now we want to solve for a different variable. This is R, so we want to get R by itself. Well, we just go backwards in reverse, right? P and T are being both multiplied by R. So how do we get rid of multiplication? By division. So let's divide by both P and T on both sides. There. R is now by itself, right? These cancel on this side to 1. This cancels on this side to 1. We get R's left by itself. And now we have I over PT. Now R is just solved for. Okay, here's a more complicated equation. We're going to solve for x. So notice that we have different variables. We have a, we have b, and we have x, right? But we're just solving for x. So what that means is x is going to have some, in our solution, a's and b's. Okay, so we solve it like any other normal equation. We're just trying to get x by itself. It's okay if our answer has a's and b's in it. So we distribute. So we get 6x minus 15a. We could probably bring down those parentheses. We don't need them anymore. Then plus 4b equals 4x minus 2. So now we're just going to bring all our x's on one side, doesn't matter what side, and all our letters on the other. I have one single x over here and an x over here. So I want to move this 6x over because then I only have to move over the 2 and it'll be done. So we do the opposite, subtract 6x. So we get a negative 2x minus 2 is equal to negative 15a plus 4b. Now we have to move over this 2. So we'll do the opposite, add 2. Here we can't add 2 to any of these because this has an a, this has a b. So we can't add 2 to any of those, so we just add it to our list of terms here. Okay. Now we almost got x by itself. We have all our x's on one side. Now we have to get x by itself with no coefficient in front of it. So it's negative 2 times x. We're just going to divide by negative 2. And we divide it on this side. And I can just divide the whole thing on that side. And now x is by itself. Okay, if you want to, you could separate instead of dividing the whole thing. You divide every term by negative 2. So it could look like this. Negative 15 divided by negative 2. Negative divided by negative is a positive, so we get 15a over 2. You could simplify that if you wanted to and do a decimal. We have negative or positive 4b divided by negative 2. That is going to be a negative 2 because positive divided by negative is a negative 2b, and then positive 2 divided by negative 2 is a negative 1. So any of those two would work. Okay, so here are some problems. Go through the videos if you have to watch it again, take notes, and then here are the problems that you can work on. Come to class with questions on either the homework or the note-taking. So just make sure that you take your time doing these problems, and they're on page 84. So all these problems. Start working on those. We'll finish them in class.